We have Dr. Fawna Korhonen, and Fawna completed a PhD in metamorphic geology in 2006, has been with the Geological Survey of Western Australia, or as most of us know it, GSWA, since 2012. And after 2 postdocs at GSWA, she has had a number of different roles, including senior geologist mapping in the Gascoyne, the specialist in metamorphic geology, and the manager of both Proterozoic margins and critical minerals teams. She is currently the Acting Director of Geoscience, and she has a very keen interest and passion in the integrity, curation, and delivery of high quality and high level geoscientific data. Please welcome Fawna.
All right, thank you. Thank you for sticking it out throughout the whole day. It's been a fascinating array of talks, and thanks again for the invite to speak again this year. So I'm going to provide a very high-level overview on the role of GSWA and an introduction or an update on a few of our flagship projects. That is going to include a few data slides and a little bit of scientific arm waving, so I think there'll be a little bit for everybody in this talk, that I hope. Okay, so before I begin, I would like to pay my respects to the traditional owners of the land on which we meet today, the Whadjuk people of the Noongar Nation. I'd like to acknowledge their enduring connections to country and also recognize that the First Nations people really were the first earth scientists of this beautiful land that's so prospective and has such incredibly complicated geology. Okay, so GSWA has been collecting geoscientific data for nearly 140 years. So back when our geologists used to make beautiful hand-drawn maps and do field work by camel. Well, things have obviously changed a lot in that time, including the fact that GSWA is a small part of larger government departments. So we are currently part of DMIRS, but that's all going to change on July 1st, as many of you are aware of, when DMIRS will be split into 3 different departments. So the GSWA will become part of the Department of Mines, Petroleum, and Exploration. And for those of you that have been in the business for more than 10 years, this probably sounds like we've come back to where we started. We've come back to DMPE. But I think the addition of exploration into the new department name is not only a nice testament to the work that GSWA does to support the resources sector, but it's really shows the importance of exploration to the state. And I think that's going to be a sign of some really positive things to come for the resources sector. So I think that's a very optimistic thing. Okay, so the main objectives for GSWA are to collect and interpret geological information. So we are not compliance, we are not regulations, we are the stewards of the state's geology. Okay, and we do that to mitigate exploration risk by understanding the evolution of the geological evolution of the state. We also do provide trusted advice around responsible legislation, policy, and land use issues. With the exception of land use, we don't make any of the decisions around legislation and policy. We provide that input. And we provide objective science-based evidence around various emerging geoscience challenges. And obviously critical minerals is a hot topic at the moment. So the core functions, this reiterates a little bit of what I've said, but elaborates. The core function of the GSWA is to understand the geology of the state. Yeah, and all of our data is publicly available. And we do this through geological mapping, the collection of geological data sets. So I imagine some of you are familiar with our geochemistry. We collect a lot of geochronology information, isotope information, various other smaller data sets, including fossils, metamorphic information. We also collect geophysical data that Betty touched on this morning. So this, of course, includes our large-scale aeromagnetics, gravity, different types of seismic, magnetotelluric. We have a little bit of work with AEM. So those are the data sets that we're largely delivering. So in addition to our own data that we manage and deliver, we also do that with data that's submitted by industry. We manage core that is submitted by industry as part of their statutory reporting, and this is particularly relevant for the EIS scheme that I'll talk a little bit more about, which we also manage. We manage the Abandoned Mines program, which I think Peter touched on today. We do have a land use planning department where we make decisions on land use and provide input into that. And we also maintain the spatial data including the mineral and petroleum titles, but as well as a wealth of geoscientific spatial data that's all available. And I'll provide a link at the very end as to how you can access some of our data sets if you don't know. Okay, I'm going to jump now to an update on some of our flagship projects. And in order of presentation, this will include the EIS scheme, which I hope most of you are familiar with. I will touch on the Geoscience Data Transformation Program, which is a way that we're trying to revitalize and make our data more usable. I'm going to spend a bit of time on WA Array, which is our deep earth imaging program. And then I'll touch very quickly on our new industry-ready graduate program, if anything as a way to promote these students, because they are being groomed for working with the industry. Okay, so can I just get a show of hands? How many people are aware of EIS? Please say most of you. Okay, good. So EIS is really kind of one of our flagship projects. It has had an annual budget, it's very well supported, of about $16.5 million. Well, that has been increased with the recent election and an election commitment to $18.5 million. And most of that bump up is going to our co-funding programs. So that's money that's going back to industry. The three co-funded programs that I'm going to just quickly walk through so that you are aware of are the co-funded drilling program, which is the largest program. It's been around since the inception of EIS back in 2009. That has an annual budget of $7 million. And then we have two new programs that have only been around for a few years. One is the co-funded geophysics program with an annual budget of 3.5, and the energy analysis program with a budget of 1 million, and that is typically very undersubscribed. So I don't know if we have any petroleum geothermal people in the room, but if you want some money from the government to do some work, which I'll talk through, that's a very, very good program because nobody buys into it. Okay, so the exploration drilling program really is, as I've said, the flagship project of EIS, and it's a competitive program that is open for applications twice a year. So the next application round will be open on August 4th, and it's open for that month. And what it offers is a 50% refund for exploration drilling projects that are capped at specific amounts depending on the type of application you submit. And one of the great benefits to this program for the state is that the material that's drilled, so the core that's drilled, is then donated to the GSWA core library after a period of confidentiality. So I can't emphasize enough how much of a resource that is, not only to the GSWA staff and our data acquisition programs, but by extension to all of you, because that core is available for everybody to look at and to sample once it's gone through that confidentiality period. So it's a fantastic resource to the state. Okay, the second co-funded program, as I mentioned, is relatively new. We're only in its third year. It's the co-funded geophysics program. And listening to the EP platform, whatever, like I mean, this would be an obvious way to integrate some amazing data collection with the services that are so readily out there nowadays. And so the co-funded program, or the geophysics program, is intended to support the geophysical exploration in the mineral resources sector. And there's a high preference given to greenfields projects, regional to camp scale. So we will look at, obviously, support applications that are at the deposit scale, but GSWA's remit really is this regional scale. So preference will be given to larger scale projects, and then critical minerals. Applications are only open once a year. That's at the first Monday in February. That's also the same application deadline for the drilling program, the second round of the drilling program, and the other co-funding scheme I'll talk about next. The first two ventures of the state were focused in different parts of the state, but Venture 3, which is this next one that will be open in February, is open to the whole state. And the whole range of geophysical applications are eligible. So this includes ground and airborne. Really, the options are, I won't say endless, but within the toolkit of geophysics, there's no restrictions. And again, a benefit to this program is that after a period of confidentiality, that data is then available for us and the public. So I think this is a really, really great program, and I certainly encourage people to tap into this. And then the last one, which I don't know how applicable this is to those of you in the room, but it's our energy analysis program. And this is to encourage exploration of petroleum and geothermal work. There's two categories that are looked at. One is the analysis and reprocessing of existing materials. So this could be looking at chemostratigraphy of old core material or paleontology or whatever, or the reanalysis of existing data. So whether you want to reprocess some geophysics, reanalyze some geochemistry, reprocess old seismic lines, that's all within scope. And then this also includes the geophysics acquisition for energy applications. And again, the applications are open the first Monday in February. Okay, EIS also funds a large part of our pre-competitive geoscience data that we collect at GSWA. So this includes our large-scale geophysics, and we've just completed, we've just completed a 100-meter line-spaced aeromagnetic survey in the Nerear terrain, which is in the northern Yilgarn. This is to really improve the resolution that we have of our existing data sets. We're almost in the process of acquiring a similar survey in the Aleron province, which is the far east. This is quite prospective for rare earths in particular. I was supposed to have started acquisition in the next couple of weeks. We're getting a little bit of pushback from the traditional owners. To be honest, this happens to us as well, and we're not quite sure when we'll be able to acquire that data. But those are our two upcoming programs. EIS also funds some of our other routine statewide data acquisition programs. So this includes, what's quite exciting for me, is our novel geochronology and isotope program. So what we're aiming to do is to get data on a range of chronometers, so age information, that have different closure temperatures. So we're able to put ages onto processes that go from, say, 100 degrees to 800 degrees and start to pinpoint the timings of different geological events. And we're also working on a variety of statewide isotope maps, which I know some people use for exploration models. And EIS also funds a portion of our geochemistry, and we're really targeting high-quality granite geochemistry at the moment. EIS also supports a lot of our collaborative projects. So we do a lot of collaborative work with various research organizations, the universities. So if there's some cool geoscience happening in WA, odds are we're either involved or we certainly know what's going on. And EIS helps us do that work. I also want to briefly mention that, and I did present this last year, EIS also funded over the last couple years the acquisition of more than 1,200 kilometers of active 2D seismic in the West Yilgarn. So this map here on the right, these red lines are the new seismic lines that we just acquired. And we're in the process of interpreting those, but I do want to just show you a little bit of the results from them. So I'm going to focus on the southernmost line that was also the longest. So this is almost 700 kilometers of seismic data. And that's shown in the black line. It went from Hamlin Bay over to the west, all the way to the Albany Fraser. And this seismic line was really intended to give us a better sense of the crustal architecture in the southwest, which we remapped in 2021 during the COVID years when we couldn't go anywhere. We pretty much put all of our nearly 100 geoscientists, that's not quite true, but we do have 100 geoscientists, but not all of them are doing this, remapping the southwest terrain. And this shows the new bedrock geology map that we released a few years ago. And so this particular seismic line crosses a number of really interesting geological domains. It goes from west to east. It starts in the Proterozoic Lewin Inlier, which is Margaret River, crosses the Dunsborough Fault, goes into the Perth Basin, then crosses the Darling Fault, which is actually one of the longest and most significant fault systems in the world. believe it or not. It then goes into the southwest terrain, which is heavily modified by Proterozoic reworking. It crosses that red line, which is the new terrain boundary between the southwest terrain and the Yilgarn. It crosses into that gray area, which is a really cool domain of hot rocks, of exhumed mid-crustal rocks that have been pushed up and exposes these kind of granulite, high metamorphic grade rocks of the mid-crust. Then steps back into kind of the more ambient Archean Yilgarn craton until we're back into the lower metamorphic grade, kind of standard granite greenstones that we see and love from the Yilgarn, and then meets up with the Albany Fraser. So it's really this beautiful snapshot of so many different geological domains and how they fit together. So this shows the final seismic image that is not yet fully interpreted. So our geologists are working really hard on getting this interpreted. We hope to present this at our open day in November. And the processing work is really great. And I do want to also point out for any of the sedimentologists in the room that we have reprocessed the Perth Basin specifically for the conditions in the Perth Basin. So it's not really reflected on this particular seismic image, but we've got some really high resolution data coming out of the Perth Basin that's been interpreted as well. And so really what we're trying to do is just, see how this all fits together. Like, can we explain any of the mineral occurrences that we see there within this structural framework? Can we see, well, we can see, get a sense of how thick the crust is? What are driving some of the mineral systems in this area? And can that be used to help with exploration models? So some really good stuff coming out of here, but come see us in November if you want to see all the bells and whistles. Okay, so that's EIS with a little dash of science. I'm now going to switch over to our geoscience data transformation program, or how we're dealing with our data. So as I said, we've been around for 140 years. We've got a lot of data. We've got a lot of new data, but we've got a lot of legacy data that we're trying to get into better shape. So our GDTP program is a 5-year, $10.6 million program, really intended to transform and modernize our databases and our data sets. This includes, I guess, our current data, but also our 140 years worth of legacy data. Whether or not we get to that part of it, time will tell. We're about halfway through this program. And really the intention is to make it easier to access all of our data, make it easier to find our data, and interrogate that. And really, we're trying to make this findable, accessible, interoperable, and reproducible, trying to create fair data, finally. And unfortunately, our databases, even internally, they don't talk to each other. We can't find things. We don't expect you to be able to find things. So we are trying to rectify that. And we want this to be fully standardized. We want this to be digitized. We want it to be very, very usable for everybody. So we're getting there. I'm going to give you 2 little updates as to where we're at with this GDTP work. There's a lot more out there that I'd either be happy to chat with you about or direct you to. A lot of work's gone into this. So the first is our discovery portal. So this is just, this is obviously not released yet. This is kind of pie in the sky where they're going with it, but they're making really good progress. So the intention is that it will be a textual and map-based searching platform to find all of the data that exists for whatever sort of search you're doing. So in this case, I think, they've typed in gold information on various samples or locations that have something with gold in them can pop up, and you can download, let's say, geochemistry, geochronology, reports, geophysics, all of it. Any data that can be linked to a place where you can find gold should be findable for you. That's the hope. So, like I said, we're making good progress there, but it really should be a game changer in how our data can be found, really, and queried, I should say. The second thing I want to just mention is the online lodgement piece that they're working through. Now, I'll be honest, I don't know a whole lot about this, but this screenshot here was based on a recent survey from stakeholders as to what are the top, well, I don't know if that, I guess the question was, what are the top 5 functions do you consider the most important in a lodgement portal? And this is the lodgement of data by the industry to GSWA. So I'm not talking about any of the compliance or regulation stuff. This is the data lodgement that you're required to do. And these little boxes in green, I don't know if you can see the text, but I guess the point is a lot of the functionality that you are requesting, that our stakeholders are requesting, is being looked at and is being worked on. And so the hope is that this is a game changer in not only the way that you guys submit your data, but it's done in a way that's standardized, that then makes it more useful to use broadly. So the hope is that this just completely changes your experience of lodging, but then our experience to be able to use it. So I think that's tracking very well, and re-emphasizing that we are engaging with stakeholders to make sure that we're hearing what you guys want and trying to deliver what is of most use. Yep. Okay, I also just want to touch base on a new team we have at GSWA. It's our Geoscience Data Integration Team, and these are the 4 fine folk that are on board. This is a new team for us. They've only been around, we didn't have them when I last spoke with you 12 months ago, so they're a new group. And they are data scientists. 3 of them have geoscience backgrounds. The other one is a data scientist. And they're working hard to integrate all of our different types of data into usable products for everyone, for you. These are some of the things that they've done over the last 12 months. You can see harmonized keeps popping up. So they're working a lot on finding ways to harmonize various data sets. So this includes, in the last few months, they've done a lot with our petrophysics, wireline petrophysics, more downhole petrophysics, gravity, drill hole logging, and we expect some really great things out of this team. Unfortunately, there's government process behind all of this, and AI and ML is a very new space for government, and we are going through all of those teething pains with this group. So the fact that they have not left us yet, and they're still fighting through all this is a great testament, but they're, especially now that our data is getting more and more findable and usable, I think we can expect some really great things out of this team. And one thing that I'm thinking a lot about is, the kinds of products that we can give that is relevant for you guys, for the industry. And, by all means, if you have ideas, I would love to hear them. Not right now, but, feel free to get in touch if you have this, this would be kind of a cool thing. Love to hear it. Okay, I'm going to switch boards now to WA Array, which is our deep earth imaging. So this initiative was born out of the fact that we know we need to understand the subsurface. Okay, and so part of the justification for that is that we want to make really good land use decisions. So we know that large tracts of land want to be set aside for things such as renewable energy hubs and things like that. So we want to make sure that we don't put those on top of the next tier 1 mineral deposit, is one example. We know we need to start looking undercover. We need to start looking deeper. We need to have a better understanding of the subsurface to be more, to de-risk the search space for exploration. So our solution to that was WA Array, which is a 10-year passive seismic and magnetotelluric program. So Betty talked a bit about passive seismic and the Oz Array program. Oz Array, which are, I think, the green circles on there, was a 200-kilometer spaced network across the country. WA Array is a 40-kilometer spaced survey across the entire state. Okay, so when this program is finished, we will have the best characterized lithosphere in the entire world. No other survey of this size has ever been done. There are 1,500 different sites across the state, which are shown by these little circles, and it's divided up into 9 different regions, which are shown here. And it takes, as I've mentioned, 10 years to complete. So the first year was in the Southwest, and data acquisition for that completed in December of 2023. I'm going to present a little bit of the results from that in the next few slides. That's the first phase where we've got a complete package of work. The second phase was in the Eastern Goldfields, and data collection for that just finished in March. And then the third phase was just deployed 2 weeks ago. We finished the deployment, and that's in the Midwest. I will say that phase 3, we were intending to go to the east. We were intending to be kind of in that area. We are having a lot of trouble with the TO access, to be quite honest. So this isn't something that's just faced by industry. We also have to navigate these relationships as well. So in the end, we didn't get them in time. Very last minute, had to switch to where we were deploying. Very stressful for the team, but I'm very happy to say that they managed to do it, which is amazing. Now, more than half these sites are not accessible by vehicle, so it is a helicopter-based program, and which is obviously very logistically challenging. At each of these sites, we are also collecting regolith material, which we are analyzing for geochemistry, ultrafine geochemistry, and heavy minerals. So at the end of this, and that will be, all this data is being released as it's going, but these are essentially super sites where we've got amazing passive seismic and MT data, but then the geochemistry and heavy minerals as well. Okay, so these are a list of some of the products that are being generated for each phase of WA array. Now, I imagine there's probably one, maybe two people in the room that understand what any of this means. I'm not one of them. So let me put it into words that I think are a little bit easier to understand. So what we're getting out of this program is really great information on the surface characteristics. And this has applications for engineering, for seismic risk analysis, and then also, as I mentioned, the soil geochemistry and heavy minerals. We're getting really great information on the crust. So we're getting, again, a snapshot into the seismicity. We are getting a sense, we can tell exactly how thick the crust is, what its composition is, and then the structures within it. We're getting information on the mantle, and that includes its composition, its structure, the way it's deforming, the way it's flowing, the temperature that we're getting through there, and then we are also getting the lithosphere thickness. So we are able to image using this passive seismic technique all the way through the lithosphere. And you might be wondering, well, I guess I'll let the next few slides answer that question. Okay, so this kind of reiterates what I've already said. Well, not so much actually. So phase 1, it was the Southwest. Those are those yellow ones. All the data and models are released for that, and I'll have a link towards the end as to where you can find that. Again, the data is there, so if you're really keen on seismic processing, you don't have to take our word, you don't have to use our models, you can do it yourself. So all that's available. Phase 2, which is in the white, the data and models for that will be released in March 2026. So we have the data, we're currently QA/QCing it, processing it, and then we'll release that in March. And then phase 3, those instruments are currently in the ground collecting data for 1 year. They just started their collection a few weeks ago. So in June 2027 2026, we will retrieve the instruments, get the data, and then a year from that, so June 2027, we will release the data and the models. So you can see why it's a 10-year program. Okay, so just a few slides on some of the results that have come out of WA Array. So this is one on seismicity and earthquake maps. So again, this is from the Southwest. So the map on the left shows the earthquakes and the earthquake swarms based on that 1 year of data collection. So I imagine most of you are aware that the Southwest is seismogenic. It's actually the most seismogenic part of Australia. So it has a lot of seismic activity, and you can kind of see that on that map. The circles in blue, or the blue circles, is natural seismicity, and that includes the Arthur River Swarm, which was between that 22, 23, where, I can't remember now, but it was hundreds of earthquakes were detected in that area. And then the orange circles is seismicity associated with mining. So we can differentiate those. And then the map on the right just shows the focal mechanisms or the stress tensors for those earthquakes, which helps you figure out why. I mean, a big question for us is, why is this area so seismogenic? It's not an active plate boundary, so what's going on? Well, having an understanding of the stress regimes might help us answer that question. And again, aside from this being kind of a cool science thing, this really does have applications to safety, to land use planning. It's got some very, very real applications. So now, going a little bit deeper, now we're in the crust. So the map on the left shows the crustal depth, the modern day crustal depth in kilometers. And, to be honest, it was a little bit surprising to see not so much the crustal depths. We expect that to be about 40 kilometers, which is roughly what we're seeing. But you can see how there's some kind of a northeast southwest trend to the breaks in that crustal thickness. And we also see that kind of trend, this northeast southwest trend. We see this in our geochemistry as well. And the structural trend, for those of you that have worked in the Yilgarn, is mainly north-south, right? All the shear zones go north-south, the foliations, the fabrics, everything's north-south. But we're seeing these very subtle, deeper signatures of something very significant happening oblique to that direction. So that's got to tell us something pretty interesting about the mineral systems, and it'll be really interesting to kind of pull that out and see what effects that's having, and why. Why do we have that signature? And then the diagram on the right is the velocity model, which is, in my mind, just a translation to chemistry or to composition. So the more red domains tend to be more felsic, and the more blue ones are mafic. It's a little bit obscured by the Perth Basin. Sedimentary rocks, I think, kind of look more mafic in this example, but they've got quite a range of velocities. And again, we're seeing that kind of oblique trend to the structural fabric. Something interesting going on there. I also just want to emphasize that because this is being done in an array, right? We're doing it as a network, not as a line. All of these models can be brought into 3D. So this just shows it's a static example, but we have the 3D models available for download. You can put all of the different arrays in there and spin it around and really start to look at these things in 3D. And again, you can focus on just your very shallow level, or you can look all the way down through the lithosphere. I guess one thing worth mentioning is that 40-kilometer spacing for exploration might seem like it's quite broadly spaced. It is for exploration, but it really is. I guess it depends on how you generate your exploration models, but it is the regional scale that we're trying to target here, and really trying to get a sense of what might be controlling the mineral systems on a regional scale. Okay, the last thing I want to touch on from WA array is the lithosphere thickness. So, that's that big chunk of rigid rock that we live on. And we know from previous work that previous models have estimated the thickness of the lithosphere in the Yilgarn at about 220 kilometers. And again, this is present-day lithosphere thickness, okay? So this is what we're seeing now. It's not saying what was happening in the Archean or Proterozoic, but what we see now. And what falls out from this data of lithosphere thickness is that you can see that in blue, which is largely in the southwest there, has a lithosphere thickness of about 200 to 250 kilometers, about what we expected based on other models. So that's consistent. Well, what's really interesting is that that's not continuous, and we definitely see thinner lithosphere as you move away from that blue domain. And what's also interesting, and this is where I'm starting to wave my arms a little bit, is that we seem to see a correlation between gold mineralization and the transition between thick lithosphere to thinner lithosphere. There's also a major shear zone there, which I'm not ignoring, and obviously, they are also related. I mean, the shear zone and the lithosphere the transition between thick and thin lithosphere is probably the ultimate control, but an interesting story. The reason I'm bringing this up is because there was a seminal paper published in 2020 by Mark Hoggard and others who showed statistically that 85% of sediment-hosted giant base metal deposits occur at the transition between thick and thin lithosphere. Okay, so they statistically showed at about 170 kilometers, a lithosphere thickness of 170 kilometers is kind of this magic window where you get sediment-hosted mineralization. And this is, really intended to, again, reduce the search space. Well, we know, that contour thickness, this magic contour of 170 kilometers, at least in WA, was very poorly constrained. There was no data there for them to devise that contour. And we know from our geochemical data sets, our isotopic information, or I shouldn't say we know, we think that those craton margins, so again, that transition between thick to thin lithosphere that you get when you move off of a stable craton, likely occurs in that dashed line. So it goes through the Officer Basin, for example, which we think might be quite prospective for copper. So I don't have my little... So if we then take that kind of model, just knowing there's a fundamental control on mineralization. I'm not suggesting the gold mineralization that we see is the same sort of model as we get for sediment-hosted metals, but there's something really interesting going on when we start thinking about lithosphere thickness and mineralization. And I think some good stuff's going to come out of this work. And we're going to have a really good picture of what the lithosphere is doing in WA in a few years' time. Okay, so just quickly to advertise the results for WA Array, should you want them, this is where they can be found. All the data is on AusPass, which is the National Passive Seismic Portal. Can also be found through Magix, which is our own GSWA data portal for geophysics. And then the report is on eBookshop. And so that's pretty findable. Okay, I'm almost done. So the last thing I just want to mention is our Industry Ready Graduate Program. So this is a 2-year program intended to train up a handful of geologists so that they are highly skilled and data literate, and then they are released back to industry. So in this program, we pay their final year of university, and then we pay them a stipend to come into GSWA for 1 year and work with us and learn all of our data, learn how we do things, learn all of our systems. And we're really focusing on those core rotations there. So we're teaching them mapping, teaching them how to deal with core, teaching them field work, how to engage with industry and government, and how to really manage and interrogate data. These are the rotations that they're currently doing. So we have the first cohort of 3 students currently at GSWA. So they've been there for 6 months. They are amazing. So come January, we're going to get another cohort to 4 at GSWA, and this will keep progressing. Now, I'm not advertising this necessarily for you, although certainly if you're eligible and you want to go back and do an honors or master's and do a year at GSWA, please consider applying. But it's more to point out, it's more to point out that keep an eye out for these grads. They're going to be applying for jobs coming out of this program in, starting soon, but every year we'll be releasing them, and they will be very good. So keep an eye out for them. All right, this is my final slide. This just summarizes some of the things that we've done over the last year. It's been a great year. Obviously, lots of things I could have talked about but didn't, which you're probably like, whew. But if any of these interest you, I'd be certainly more than happy to talk through them. But I also want to mention that we've got a very passionate group of very knowledgeable geoscientists at GSWA. They would love to talk to you. If you want to come in and pop in for an hour and chat about something, I can find out who would be the best person for you to talk to based on what you want to know. And so it covers a lot of it, but it's not everything we do. We do cover a lot. So, all right, thank you. Thank you for your time.